Hey guys, this is 5.4 from Pre-Cal. This is the last of our crazy memorizing from Chapter 5. We will be doing product to sum and then sum to product. All right, so let's start off with product to sum formulas. Probably the worst memorizing you'll encounter, not gonna lie to you, okay? But don't fret, because to be honest with you, when you get to calculus and AP Cal, we don't see these specific formulas, okay? So don't stress it if these are a little too overwhelming. We have sine of one value times sine of another, and then cosine of two separate, and then one of each, sine times cosine and cosine times sine. They all have a half, and notice we're going from product multiplication to sum, so adding and then also subtracting. We have cosine, you subtract the two. Here these are opposite, cosine, and then add the two. And for these bottom, we have sine adding the two values, plus and then minus, sine subtracting the two values. Okay, so let's just practice using these really quick. Here we have sine times sine, so we're going to this first one. This is going to become half times cosine of the first minus the second, and then minus cosine of adding them. Okay, so this just cleans out to be half of cosine of x minus cosine of 5x. Okay, and because there's a variable of x, there is nothing more we can do here, and we stop right at this point. In our next questions, you'll see we don't have variables of x, and we can keep going all the way through. Okay, so looking at our next one, 2 sine of 45 degrees times cosine of 15. I keep telling you in these videos that our goal is to use the side of the formula that gives us values on our unit circle. Now, although 45 degrees is on my unit circle, 15 degrees is not, okay? So I have sine times cosine, and this one has a coefficient of 2. All right, so I have 2 times whatever, so 2 times whatever this formula gives me. This formula, the sine times the cosine, has the half, and then a sine of the two values being added. So I have 45 degrees plus 15, and then plus sine of the two values being subtracted. Okay, so this 2 and this half are going to cancel out. Okay, then I'm gonna come down over here. I have sine of 45 plus 15. I have 60 degrees, plus 45 minus 15 is sine of 30 degrees. At this point, 60 and 30 are both values on my unit circle. So sine of 60 degrees is radical 3 over 2. And then sine of 30 degrees is 1/2. Okay, I have a common denominator, and then I'll just write this as radical 3 plus 1 over 2. And I am done with this question. For this next question, I want to use it as a little bit of a proof. Notice that this one reads cosine of 5 pi over 6 and sine of pi over 3, which are both on our unit circle. Okay, so on my unit circle, let's go without using these formulas first. Cosine of 5 pi over 6 is a negative radical 3 over 2. And then times sine of pi over 3 is a positive radical 3 over 2. Okay, if I were to multiply those together, a negative and a positive make a negative. Radical 3 times radical 3 is 3, and 2 times 2 is 4. Okay, so again, we don't need the formula for this one because it is on our unit circle, but I just want to show you how it does work out both ways. And again, you could always test this out with your calculator. So cosine times the sine is this last one here. Okay, I'm going to move up a little bit. So we are going to write half times sine of both values being added And since I don't have a common denominator, I'm going to leave a little gap right here to do that step. And then we have minus sine of both of them being subtracted. And again, going to leave a little gap to get my common denominator. All right, so getting common denominator, I'm going to multiply by 2 over 2. So I have a denominator of 6. And then this will be a 5 pi over 6 plus a 2 pi over 6. So what I'm really working with here is sine of 7 pi over 6, bringing down this 1/2, minus, so over here it's going to be a 5 pi over 6 minus 2 pi over 6. So now I'm working with sine of 3 pi over 6, which is really just sine of 1/2. So make sure you look there for a unit circle. So now I'm going half times sine of 7 pi over 6 is a negative 1/2 minus sine of, remember this is 1/2, is 1. And now I'm just going to work here to get common denominator. So I'm going to say half times negative half minus 2 over 2. I have negative half. Oops, sorry, that negative shouldn't be there. I'm writing this half first. So I have half times negative 1 minus 2 is negative 3 over 2. My answer is negative 3 over 4, which should match up perfectly with what I did without using the formula. Okay? So on this next question, we have cosine of 15 times cosine of 45. Now I know cosine of 45 is on the unit circle, but since 15 is not, we're going to have to use the cosine times cosine rule. Okay? So we have half times cosine of both of them being subtracted. So I have 15 minus 45. Now remember that in subtraction you really have to pay attention to the order. So be careful not to flip these. It'll give you a different answer, okay? Plus cosine of both of them being added. Okay, that leaves us with half times cosine of negative 30 degrees plus cosine of 60 degrees. Okay, now remember negative 30 just means instead of going up 30 degrees, we go down 30 degrees on the unit circle, or you can take a quick moment to find coterminal and work that way. Either way works. We end up here with half times cosine of negative 30 is a radical 3 over 2 plus cosine of 60 is 1/2. And again, all of this we get from our unit circle. If you're my student, I hope you have it memorized well enough to do that quick. So now we have half times radical 3 plus 1 over 2. And then multiplying that 1/2 radical 3 plus 1 over 4. There you have it. Now let's look at the second set of formulas, the sum to product formulas, okay? And that is that we're converting when we have two separate trig functions being added or subtracted with values that are not on a unit circle, we can put them over to the right side of this formula, okay? So for this first one, A, we have a variable of x in our first two, so we're not going to be able to get down to one clean number, but we are going to be able to just practice converting it, okay? So sine of a value plus sine of a value is this first one. I'm going to have 2 times sine of both of them being added divided by 2. So I have 2x plus 3x over 2. And then times cosine of both of them being subtracted, 2x minus 3x over 2. And now I'm just going to clean that up a bit. We have 2 times sine of 2 plus 3 is 5. So 5x over 2 times cosine. 2 minus 3 is a negative 1, so negative x over 2. All right, and that's the most we can clean that one. Let's practice one more of those. We have cosine of a value minus cosine of another. So we're looking at this bottom one. There's a little negative there. Be careful not to miss it. So we have negative 2 times sine of both of them being added. Now make sure not to take this sign into account. This sign just tells you which formula to pick, okay? Times sine of both of them being subtracted. And again, I'm just going to clean it. We have 6x over 2. I'll write it and then we'll reduce it. And then here we have 2x over 2, which we can clean this up one more time. And we're done. So I'm going to use this next one as a proof because both 90 and 30 degrees are on my unit circle. If I go straight to my unit circle, sine of 90 is 1 minus sine of 30 is 1/2. And 1 minus 1/2 gives you 1/2. If I were to use a formula, I should also get 1/2 as an answer. So sine minus sine, I'm going to use this formula here. I have 2 times sine of both values being subtracted divided by 2 times cosine of both values being added divided by 2. Okay? So now we have 90 minus 30 over 2. We end up with 30 degrees. Times cosine. 90 plus 30 divided by 2 gives me 60 degrees. And on my unit circle, sine of 30 is 1/2. And cosine of 60 is also 1/2. Okay? 2 times 1/2. Half of 2 is just 1. 1 times 1/2 is just 1/2. All right? Now let's move on to one more of these. We have cosine of 75 degrees plus cosine of 15. So neither of these two are on my unit circle, so I'm going to go to the formula of cosine being added with cosine. And I have 2 times cosine of both values being added divided by 2 times cosine of them being subtracted divided by 2. Okay? So 75 plus 15 divided by 2 gives me 45. And then we have cosine of 75 minus 15 divided by 2 is going to give me 30. So now 2 times cosine of 45 is radical 2 over 2 times cosine of 30 is radical 3 over 2. You can multiply straight across. I personally like to reduce as soon as I can. So I'd call this 2 over 1, and I know that when I'm in multiplication, any numerator can reduce with any denominator. So now I just have radical 2 and radical 3, which give me radical 6 over 1 times 2 is just 2. And we are done with this one. So before we close out this section, let's check out two verify questions and see how they work with these formulas. So if I want this big complicated right side to say tangent, well, sine over cosine will give me tangent, but I can't reduce those yet because they're separated by addition or subtraction. So if I can use one of the rules to change these to being separated by multiplication, then I can start simplifying and make these tangent over cosines. I shouldn't be sine over cosine to say tangent. So let's start off by using our sum to product rule. So sine of a value minus sine of another value. Okay. I have 2 times sine of both values being subtracted divided by 2 times cosine of both values being added over 2. So that's, I just changed my numerator. Let's change my denominator. Cosine of 2 values being added, I have 2 cosine of both values being added times cosine of both values being subtracted. So now that I am in multiplication, I am allowed to reduce one numerator with one denominator. So notice that these 2's are going to cancel. Now I have the freedom here to either clean the insides first, or if you can catch that this cosine is identical to this cosine, then you can already cancel them out. Okay? And again, they have to be identical to the t, every single thing. Okay? Notice these 2 are not identical. One is a sine and one has a cosine, but the insides are the same. So what I am left with is sine on my numerator. 3x minus x gives me 2x. 2x over 2 just gives me x. Over, the only thing I'm left with on my denominator is this cosine of 3x minus x is 2x. Divided by 2 is just x. Okay? And now, remember, my goal is to get a tangent of x, and sine of x over cosine of x equals tangent of x. I did it. All right? Let's look at one more that looks just like this one. All right? I want this complicated side to end up saying 1 over tangent of 2x. So again, I cannot start canceling these out until they're separated by multiplication. So again, I'm going to go sum to product rule. So sine of 2 values being subtracted is going to become 2 times sine of them being subtracted, 3x minus x over 2, times cosine of them being added, divided by 2. There's my numerator changed. Now let's change the denominator. Okay? The cosine minus cosine is going to be a negative 2 sine of x plus 3x over 2 times sine of them being subtracted, which is x minus 3x over 2. Let's check if we see anything that is completely identical, okay? If I look at these two signs, no, these two, they look identical on the inside, but one's sine and one's cosine. These, one is addition, one's subtraction, and these are going to end up with an opposite sign. So let's start cleaning first. I do see that the 2's cancel. We can do that. So I'm going to end up with sine 3x minus x is 2x, divided by 2 is just x. And then I have cosine of 3x plus x is 4x, divided by 2 is cosine of 2x over negative sine x plus 3x is going to be 4x, divided by 2 is just going to be 2x. And then times x minus 3x over 2 is going to be sine of negative x. Now, in my class, we don't go too deep into even and odd properties, but I will just give this one to you. Again, this is for my students. Because sine functions are odd functions, this negative can come out, and I can take it to the front, just the negative. Okay? So my numerator would say sine of x times cosine of 2x. And then if I take that negative out, a negative and a negative become a positive, and I'm just left with sine of 2x times sine of x. Now these two signs cancel. And I have cosine of 2x over sine of 2x, okay? If the insides of these trig functions are identical, I can apply the quotient rule or the reciprocal rule, okay? So cosine divided by sine is cotangent, and I keep the inside of 2x. But remember, my goal is for it to say 1 over tangent. Well, the reciprocal rule of cotangent is 1 over tangent, and then keep that same inside, which is 2x. And now I have what that left side reads.